And now I would like to present Burhanuddin Baki. He is currently a researcher in Center for Modern Thought, University of Aberdeen in Scotland, and his interests are really wide. I can quote: quantum computability, ergodic number theory, and internet and hacker culture. And I would like to stress this, that Burhanuddin is the author of the first extended study of Badiou's use of mathematics in being and event. The book is entitled Badiou's Being and Events and Mathematics of Set Theory. Now we can hear the presentation called On the Prospect of Mathematical Philosophy. Please, the floor is yours.
Thank you. Hello. Thank you very much, Michael, for the introduction. My name is Burhanuddin Baki, and I'm a self-hating academic from Malaysia. Some people call me Burhan Baki, and that's okay. But I am in no way related to the fictional Bourbaki. I always wanted to make that joke. I finally have the audience for it. Thank you also for this conference and for... Okay. Thank you also for this conference and for inviting me, Yana, Michael, and others. Also Nick, who, by the way, introduced me to Badiou's work about a decade ago in Aberdeen. Okay, so the issue in question for my talk is the study of Badiou's mathematical meta-ontology specifically and mathematical philosophy in general. Some potential projects I have been tentatively thinking about and abandoned. Some possibilities for research I have been envisioning. Some hopes I have been entertaining in regard to the general field. Maybe also some pointers on how I myself, if I had my way, would like the field to evolve through the next decades. But I am in no way a Badiou scholar. I have not read everything on and by Badiou that has come out. By mathematical philosophy, I do not mean the philosophy of mathematics. By mathematical philosophy, I do not mean the philosophy of mathematics. I mean the philosophy conditioned or forced by mathematical truths. The audacious importation of mathematical truths into philosophy through the construction of a generic blockchain instead of the other way around. Anyone who wishes to engage in creative philosophical thinking can find many possibilities to work on with Badiou's meta-ontology and with mathematical philosophy. It is impossible that I will be able to pursue all of them. I offer them here not to put dibs or call shotgun on them, but with the hope that someone with more resources, more patience, and more cognitive horsepower might take them up. A philosopher is nobody but someone who admits his own mental and epistemic limits. Socrates/Plato, after all, more or less defined the philosopher as an idiot who realizes he's an idiot. Maybe I might give up and abandon all of this. So my intention here is to sketch some of the routes that I find most interesting. I'll present ideas and possibilities that are still underdeveloped and probably half-baked. My format is not a detailed or developed exposition, but a schematic and hasty report of my thoughts. I feel increasingly comfortable with this type of format, and I've always found Badiou's very schematic, perhaps architectonic way of presenting his ideas to be useful. Like some people, I find writing long and elaborate pieces hard. The mathematician Michael Atiyah says, mathematicians are trained to be very precise and brief. You don't do padding, whereas in the literary style, things have to be decorated, embellished, elaborated, and expanded. I say briefly, and that's it. The philosopher Michel Serres also says, mathematics teaches rapid thought, and economy of thought. When you approach me with structure isn't enough, you've got to add all the intermediate steps. This is not mathematical thought. Philosophers love intermediate inferences. Mathematicians gladly dispense with them. There's a slowness particular to philosophers that often strikes me as affectation and a speed accompanying mathematical thought that plays with amazing shortcuts, unquote. Okay, so the ontology equals mathematical equation is a genius hypothesis. Being is suddenly thinkable in a purely technical sense. Okay? Let me describe this analogously from a documentary movie I saw on the long plane ride here. This is the subfield of regenerative medicine right now, often called, this is a subfield of regenerative medicine right now called the field of life extension. Scientists are trying to solve the problem of human aging, and more bombastically are trying to make the human body theoretically immortal. Aubrey de Grey, the most well-known researcher in this field, has a nice elevator pitch. The person who will live to 1,000 years might already be alive today. The prospect of the science of immortality, this prospect of the science of immortality, what does it mean philosophically? Among others, it withdraws the question of death a little bit away from the analytic of finitude that we see in various philosophies. From Socrates' comparison of human versus divine wisdom to Heidegger's well-known foundational starting point in being and time. With regenerative medicine, death is suddenly converted from being an existential to a technical problem. So this is the exact quote from Aubrey de Grey. Death becomes a technical problem, not the existential problem. The same thing happens, I think, when ontology becomes mathematics. The task of thinking being qua being is suddenly secularized and outsourced away from the philosophers to the technical groundwork of the mathematicians. So you don't learn about being by reading poetry or studying Greek mythology like Heidegger. Okay, so first I will get out of the way what I see to be the most obvious direct path forward. The second part of my talk will haphazardly list, until I run out of time, some other things that I idiosyncratically would like to see. I would like to see more detailed ontology to meta-ontology and mathematics to philosophy analyses of Badiou's work. 7 years ago, I tried to do this myself by examining the set theory in being an event. And some of you might know I'm also working on a similar analysis of the topos theory and categorical logic in Logics of Worlds. And then the third being event book, which we discussed yesterday. Even for Badiou's earliest meta-ontological work, concept of model, I still see the possibility for a lot of explication and expansion. Model theory is not a tiny field, and potentials for meta-ontological incorporations are various. Not to mention when model becomes topos. The intention behind these prospective ontology to meta-ontology analyses and extensions of Badiou is modest, but it is vital to the future health and direction of the field as a whole. The basic assumption is that the deeper mastery of the various meta-ontologies demands beforehand a careful study of the mathematical truths conditioning them. A deeper and fruitfully generative understanding of the meta-ontology requires a deeper understanding of the mathematics. Ontology to meta-ontology analysis needs to be done with each meta-ontological work, and also done to a sufficient level of thoroughness with each mathematical subfield whose definitions, theorems, proofs, lemmas, conjectures, and frameworks play a crucial role in those respective texts by Badiou. There is set theory, topos theory, serial numbers, forcing, transfinite numbers, and so on. For each piece of mathematics, the task is to understand it on a deeper and technical level, separate from the composabilized meta-ontology that was later conditioned by it. And remember that when a mathematician says he understands a mathematics, he means understanding it as ideally what Alexander Grothendieck wanted mathematics to be understood. To understand it to your bones, such that it becomes the most immediate and expansive part of intuition and your mathematical worldview. Closer than your own jugular vein, to use the beautiful expression from the Quran. This is different from just understanding a piece of mathematics on a superficially technical level. As any mathematician, great and minor, and Pierre here is one of the greats, I will admit, achieving this understanding and building the vista of mathematical intuition can take years with great effort, and impossible without sustained focus. That is, unless you're John von Neumann. I remember Barry Mazur, the great Harvard mathematician who I worship, admitting somewhere it took several decades for him to understand the mathematical notion of the motive. It is only by immersing oneself within the dark and dirty guts of the mathematical architecture in all its messy technicalities can a deeper, more meticulous, and more expansive understanding of the meta-ontology be achieved. And even possibly even more expansive than what Alain Badiou himself intended. Here's a crucial part that cannot be stressed enough if you want meta-ontology to have a future. Badiou's meta-ontology is smarter than its author Badiou. Badiou's equation is smarter than Badiou himself. In the same way as relativity theory is smarter than Einstein, who still remains undeniably the greatest physicist of the last century, to the work of later physicists, Einstein's theory later went into other richer directions than Einstein himself did and was not anticipated. Later and more contemporary developments in the specific mathematics must also be understood. We've seen this here in this conference. This could perhaps help us extend, modify, invert, or radicalize the meta-ontology. This later task of creative philosophical composabilization is without doubt the hardest part of the venture, insofar as doing anything new is difficult. Let me demonstrate what I have said so far for the example of set theory and Badiou's being an event. For further possible work, I would like to see closer analyses and explication to the proofs of the more famous theorems used in the set theoretic meta-ontology, like Gödel's various theorems, completeness, incompleteness, and the ones on consistency. Also, the various proofs to Cohen's various theorems in his technique of forcing. And also the various crucial theorems and definitions appearing along the way that are indispensable to the ontological infrastructure of forcing, the definition of the generic filter/ultrafilter, the definition of the forcing relation and language, Mostowski, and so forth. I have faith that good meta-ontological papers can be produced for each one of these. For example, I believe some good research can be conducted by simply studying very carefully the complicated structure of the generic filter in forcing and its related structure, the dense set, or domination in being event. Some of you might know that the structure almost has no role or a different one in the later reinterpretation in terms of Boolean value models. I also noticed recently that the concept of the generic can be defined in terms of the mathematical structure that famously appears in Lacan's meta-ontology, the open set, which serves as one of his figures for a free and open structure. To put it in technical terms, the generic set intersects every dense set, but a dense set can also be defined as a set that intersects every open set. So the generic set, which Badiou meta-ontologized, is the set that intersects every set that also intersects every open set, which Lacan also meta-ontologized. Another interesting observation, although I have no idea how to develop it, the definition of the dense subset in terms of forcing posets is surprisingly quite similar to Spinoza's original definition of God in his Ethics, as that which has an infinity of attributes. Meta-ontological composabilization should also pursue all the most crucial later developments in the mathematics of forcing. Certainly Cohen's later proof of the independence of the axiom of choice with respect to ZF. Boolean value models, forcing recast in terms of categories and sheaves from tyranny, iterative forcing, forcing axioms, inner models related to the Woodin stuff yesterday, Bohr relations, proper forcing, and so on. Okay? Then we can zoom out. We can examine the rest of set theory meta-ontologically in addition to fields adjacent to it, like measure theory and certain fields within computer science and the theory of computation. Only after that can we move on to more recent and more contemporary research in set theory by reading the journals and recent literature. But suppose ZFC set theory is problematic for you, then investigations into different set theories and meta-mathematics can be pursued. Taxonomizing and mind mapping all these alternative set theories and different meta-mathematics will take too long here. Even for type theory, we have the classic one introduced by Bertrand Russell to the more recent and still incomplete homotopy type theory based on the univalence axiom by the great and late Vladimir Voivodsky. It is safe to say that different meta-ontological architectures and different philosophical composabilizations could potentially be constructed out of each one of these alternatives to ZFC set theory. All of this does not exclude the other fields of mathematics that are not directly meta-mathematical, like dynamical systems, stochastic differential equations, and so forth. And then after all that, the major task confronting us now is constructing a new and robust philosophy out of all of these mathematical truths. Along the way, these meta-ontologies can be brought in conversation with the ideas of your favorite philosopher, who may or may not already be mathematically informed. That is, provided such comparative analyses can help illuminate the ideas of all sides and lead to new generic blockchains. Just take your pick, depending on your level of philosophical erudition. Lao Tzu, Frege, Quine, Lacan, Deleuze, Al-Khwarizmi, Derrida, Xi Jinping, Kojin Karatani, Steve Bannon. Okay, next section. If Badiou's meta-ontology takes the phenomenon and idea of the event as central, then certainly any study of high-impact novelty, particularly if it is scientific or even mathematical, should be examined. If you are willing to look hard enough, I wager that almost any field or subfield within the sciences has its own specific figure for the new or for thinking the new. Let me pursue one obvious possibility. A large portion within the economic sciences and theory, due to the use of highly sophisticated mathematics, might prove highly suited for thinking the event in quasi-Badiouian terms. The economic sciences have various names for novelty, but the most well-known is innovation. Countless formal investigations using highly sophisticated mathematics have been produced going back to Joseph Schumpeter's theory of creative destruction, and perhaps going even back to the early Adam Smith days of economics as his own discourse. How to reconcile these with the Badiouian meta-ontology of the event? Then there are various mathematical models of economic growth, such as the standard equations by Solow and Swan. A lot of these type of models take technological innovation, technological invention, itself a type of event, as the X factor. Then there are various specific theories of innovation, with the most famous, in my opinion, the most philosophical and counterintuitive, being Clayton Christensen's concept of disruption. This is the assumption. If, according to Badiou, that philosophy essentially post-evental thinking, then any other thinking of the event could relate and expand philosophy, even though doing philosophy is a different skill set altogether. Some of us Marxists can discuss and complain about what happens when we replace the thought of the event with the thought of innovation, a term sutured to certain economic and political axioms of entrepreneurial capitalism. Axioms that are in contradistinction to the communist hypothesis. But is not an entrepreneur, like a philosopher, also someone obsessed with a new idea and wishes to build something out of it? Perhaps the rebranding of the event to innovation can help us. Perhaps rebranding the event to innovation can help us with getting that research grant we always wanted. Some of us might have already seen incorporations of Badiou's philosophy into research within MBA producing university departments. Then again, Harvard Business School management theory professors and McKinsey management consultants have bastardized Thomas Kuhn's concept of the paradigm shift, turning it into an empty buzzword. Interesting tidbit. Someone back home, Mr. Goh Peng Oi, studied category theory very carefully in the 1980s and amazingly produced a business model of technological innovation out of it to build his own computing business. He is not an academic and has no education background in math or in philosophy, so the fact he was able to do this from reading Goldblatt and the sheaf theory textbooks is amazing. I met him and he clearly understands what he's talking about. In fact, his business is so successful in Asia that he's a billionaire several times over. Of course, I can mention other billionaire philosophers like Soros and so forth. On the reverse side of innovation and economic growth is economic collapse. For a more anti-academic register, which I kind of like, one cannot help but find relevant the works of Nassim Nicholas Taleb, a thinker today of the highest order. Eli Ayash has produced some extraordinary work analyzing Badiou and Taleb. Nassim Taleb's books are relevant, first because he has his own direct name for the event, the Black Swan, with an erudite, robust, and well-developed philosophical analytic to match. His thought is also relevant because of the contrarian independence of his thinking, his careful attention to ideas from past philosophers, and most of all for his meta-ontological thinking, his application of mathematical methods from statistics, probability theory, and mathematical finance. And he has proposed his own ethics for preparing, encountering, and responding to black swans, or the events. This is given his beautiful and breathtaking analytic treatment of antifragility and his injunction of skin in the game. Certainly all I have said about economics could be done for subfields within mathematics itself, even possibly for fields which are not directly mathematical or foundational, provided we can do the work. Just for fun, let me give two easy to explain examples. The first is an easy one from combinatorics, and the second a highly technical one from geometry. The pigeonhole principle in combinatorics. If you have more pigeons than pigeonholes, and you have to allocate the pigeons into the holes, then you can be sure that there's a hole with more than one pigeon. Okay? So for example, a room has 13 people. So a room has 13 people, 1, 3. Then you can be sure that there exists at least a pair of people born in the same month. Because there are 12 months, pigeonholes, less than the number of people, 13 pigeons. This is what mathematicians call an existence result. It gives the minimal requirements for something to exist. Having more people than months is the minimal requirement. In the mundane movement from 12 to 13 people, a miracle happens, an event. One of the main thematics of extreme combinatorics is that if an ontological entity is big, dense, or complex enough, an event of structure can take place, sort of like the reverse of the third thermodynamic law. My second example takes the figure of the event as what mathematicians call a singularity. What is a singularity? The quickest crude definition would be a point where smoothness fails in a spatial structure. So that is singularities, where smoothness fails. It can be a point where something becomes infinite, like in a graph that goes vertical. Or a point where two lines cross. Or a sharp inflection point. The famous result in the mathematics of singularities are beautiful. Okay, I was discussing this yesterday about René Thom's work. Let me give one famous result, the resolution of singularities blow-up theorem for field of characteristic zero. This theorem is due to Heisuke Hironaka, which helped him win the Fields Medal, I think around the same time as Paul Cohen. Suppose you have a shape containing a singularity, an event, so like a sharp inflection point. Can you always convert it into a smooth shape without a singularity, without losing some important information? Yes, according to the theorem. Hironaka mentions the example of a roller coaster track. So a roller coaster track. By design, the track cannot have singularities, cannot have inflection points. Otherwise, the sharp inflection points would be dangerous. But if you examine the shadow of the roller coaster on the flat ground underneath the roller coaster track structure, so we talk about a roller coaster and the shadow of the roller coaster track on the ground underneath it. But if you examine the shadow of the roller coaster on the flat ground underneath the roller coaster track structure, then you could have sharp inflection points, depending on where the sun is located. So you could say spatial events in the shadow can be removed and parametrized into a smooth shape without events, without losing any information. Compare this sequential process of blow-ups in Hironaka's proof, for example, to what happens to a situation in set theory, following from an event, leading to the construction of a new generic model and generic blockchain, incorporation of an event into a new situation or structure. But are these all mere metaphors or simple historical confluence between philosophical and mathematical ideas? The more difficult question would be how they could be used for further creative and universalizing philosophical composabilization. I've written somewhere that methodologically speaking, moving from mathematics to meta-ontology, from the mathem to the philosophem, is somewhat difficult or problematic if the mathematics in question is not meta-mathematical. Producing a universalizing philosophical system out of a set theory or category theory is a different matter from doing so out of, say, the mathematics of ergodic theory or from the Solow-Swan equations of economic growth. Badiou's genius recognized the way that the mathematics of ZFC was able to subtract itself from any specificity. This is due to ZFC mathematics being essentially empty and based on the void of the empty set. Mathematics is really about nothing, which is why it's able to be about being qua being. I've quoted elsewhere that Bertrand Russell defined mathematics as the subject in which we never know what we are talking about. But my favorite quote comes from John von Neumann, who I mentioned earlier. When a student complained that he did not understand a mathematics lecture, von Neumann responded, "In mathematics, you don't understand things. You just get used to them." A discourse that studies only specific types of beings and specific regions of being, such as economics, biology, or algebraic geometry, has issues if it's thinking about ontology and about the event, wants to pertain about being an event in the most universal level. So the metaphysician's mistake of forgetting to think being itself as such, this is still there. This despite the fact that one of the main points behind the mathematics of forcing in Cohen, given in his locality of forcing theorem, is that it miraculously allows moving from the local to the universal, from the domestic resources within the situation to the general universal truth following from the construction of a generic blockchain. Forcing provides the means by which we can explicate the notion of global, infinite, absolute, and transcendental truth in terms of local, finite, relative, and immanent resources, sort of a way to diagonalize across the circular apparatus of hospitality given in Levinas and Derrida. The pertinence of this result, I think, has not been fully appreciated meta-ontologically. So let me end here with short remarks about two other possible proposals. The first is the possibility for what I call reverse meta-ontology, which I've sort of talked about in previous publications. Reverse meta-ontology. So suppose Badiou's proposed meta-philosophy is correct. Okay? So philosophy can only be at most meta-ontological. Ontology proper can only be mathematical thinking. Then what to make of other philosophies of ontology, such as by Heidegger, Camus, Dostoevsky, Sartre, Nietzsche, Kierkegaard, Buddhist philosophy, and so forth? Should their lessons regarding being be completely rejected if they are not directly mathematical? Or do they contain some unconscious mathematical trace? So the question is, can we read Heidegger's Being and Time and distill its ontological propositions, if we accept them, back into mathematical theorems, despite the obscurity and strange lack of formalism in the original language? Can we reverse engineer Sartre's Being and Nothingness to and construct a solution to some outstanding mathematical conjecture, good enough to be published in a mathematics journal? Could this be a way, contra Badiou, for philosophy to be able to instigate events within the realm of mathematics? What theorem served as the condition for Sartre's slogan, existence precedes essence? Or will the philosopher, insofar as he remains a philosopher, always be behind the times when it comes to ontology? Okay, so that's all I want to say about that. So last possibility. I've somewhat alluded to it earlier. Back home, I'm currently part of a research group on Bitcoin, cryptocurrencies, and blockchain technology. The quickest true definition of cryptocurrency is internet money, or digital asset. But there are certain decentralized and anti-statist features consistent with Badiouian politics, like lacking a central actor, though this can be disputed, like a central bank or government controlling its creation, use, and circulation. Okay? So Bitcoin is the first cryptocurrency and also currently the most famous ones. But there are others with different technological features like Ether, Monero, Ripple, Dash, Steemit, Litecoin, Nano, IOTA, and so on. The history of all valid transactions that have ever occurred for a particular cryptocurrency are given in an accessible online ledger called the blockchain. So this is the blockchain. This online ledger listing all transactions. It is a concatenated list with certain security, cryptographic, and aleatory features of all the transactions that occur in a form of a digital and decentralized consensus. These transactions are often publicly viewable, identifying the coin and the wallet from and to which it is transferred. Note that the technology is developing very, very fast, and it's becoming difficult to define what a blockchain is per se. Other possibilities for structuring the ledger include the Tangle for the IOTA coin, the IOTA cryptocurrency, and lattices for the Nano cryptocurrency. So my observation is not the generic set in Badiou and enforcing, also a kind of communal and decentralized ledger. Generic models and cryptocurrency ecosystems are former examples of ledger-based structures. A blockchain is a form multiple of anti-statist truth. The dissident development of a blockchain is also the result of a kind of truth procedure supported by the subject/nodes that engage and have faith in what the coin means, a faith routing system, so to speak. For Badiou's meta-ontology, the ledger contains the blocks which are inspected in time that are decided to belong to the event. This ledger determines the propositions that hold true in the new ecosystem. There was an interesting post on Reddit a few weeks ago proposing that subjective time itself is itself a blockchain, with the neural nodes in the brain forming the subjects. Although, in my opinion, the original poster's understanding of the subject is perhaps closer to the crude Cartesian analytic of consciousness rather than the analytic of the subject that we get from Sartre onwards. The dissident and counter-statist construction of the generic set, as analyzed in Badiou's meta-ontology, can be compared to the idea of decentralization for cryptocurrency ecosystems. Nevertheless, at the moment, not all cryptocurrencies want to be decentralized, like the Ripple coin. Governments like Venezuela have even launched their own national blockchains. More countries will follow suit within the next few months. The blockchains of the power set of the state will become the norm for financial systems, replacing paper and metal fiat currencies. Moreover, complete decentralization can never be achieved for a cryptocurrency. Arguments and feuds have been occurring. The original politics of the blockchain is not communist or Maoist. The original motivation behind the politics of the blockchain has been anarchist, the name for another possible politics of anti-statism. In fact, by definition, the most directly anti-statist politics there is, albeit one that is not entirely inconsistent with capitalism. At the moment, the dominant ideology within the general cryptocurrency community is crypto-anarcho-capitalism, plus Silicon Valley techno-utopian libertarianism. I've read recently there's even a cryptocurrency called ontology, whose price has been going up these past few days. Although some of you might know that the computer and information science field of formal ontology is slightly different from philosophy. I've also mentioned the case of forks, where the subject in the generic blockchain argue amongst themselves on the future direction of their situation, leading to the generic filter breaking into two. Like in the case a few months ago, when Bitcoin split into Bitcoin Core and Bitcoin Cash. In the communist blockchain, we can think of the various Leninist, Trotskyist, Stalinist, Maoist forks. Then we can think about the various forks that have happened in the generic blockchain in psychoanalysis, like Lacan's notorious hard fork. So to complete the list, we can think of all the various forks from the Heideggerian legend. I end here with an idea by Chris DeRose, a Twitter influencer, podcaster, and online polemicist / troll for thinking the blockchain. It might help us think in economic and calculative terms the subject's militant faithfulness in a particular truth. DeRose proposed thinking cryptocurrencies in terms of digital fidelity. You own a cryptocurrency like Bitcoin because you are committed to it and its corresponding generic model. Currency is a quantization of faith, an indivisible unit of fidelity. No way to know if a blockchain ecosystem and its corresponding coin will succeed or not. Like communism, almost all cryptocurrencies have failed. To use Badiou's term, the faith in the event is not wholly derivable from the encyclopedia or from the resources of the situation. Your commitment to the cryptocurrency is, to use the term by Herbert Simon, bounded rationality. To use Derrida's term, a decision is an impossible possibility. This commitment does not exist on the level of what is currently known within the existing situation. Some of you who know classic game theory know about the strategic function analyzed by Thomas Schelling to being more committed in comparison to being more open about certain ideas and actions. Okay, almost done. Cryptocurrency people have a term called hodling. Those who hodl are the true militants of the truth procedure. Hodlers will keep their coin no matter what, despite the positive and negative change in fiat price or status intervention. So Badiou is sort of a hodler of Maoism and of May 68. Money and systems of private property are many things. Among others, it is a language, though imperfect for determining what is good and bad, valuable or worthless. To own and use a money like a banknote is to have faith in the violence of the economic linguistics. For example, the subject has fidelity in the representation of value proposed in the US dollar, given by the US Fed and the US Empire. To have faith in academia, in the university, is to have faith in its own currency, the currency of reputation, the currency of respect, the currency of citations from other academics. Okay? As Rose tells us, the coin is a subjective unit of digital trust. What is interesting is that this faith can be calculated and traded, sort of like barter, as what Nick said earlier. Subjective fidelity has been commoditized as capital in cryptocurrency. Blockchain is the generic filter undergoing the map of commodification. So the question is, can this forcing ever be communist? Thank you very much.
Thank you for your talk, Burhanuddin.